I'll show you. I hope you're ready to roll. Here we go. Okay. Few items. 1. I don't know if it's just coming off a homecoming weekend or what. Last hour was extra verbal.
Not today.
Chill. Okay? Stay on target. 2. No daily quiz, no homework, because we didn't finish. Today, we're going to finish 3.5. It should not take long. Move straight into 4.1. I'm going to hand out the packets in a minute. Okay? If we miraculously get both done, well, I got to think real hard about what we're going to do for our assignment. Okay? No. 3, now that Caden has opened his flapper, and I think about this. I was going to give y'all credit for winning, but then I found out why you won. You only had like 22 kids on the team. You just beat up a bunch of freshmen.
Yeah, you're not wrong.
We should score like.
You're not wrong.
Hey, it's still a win.
That's not a game. That's just bullying. Dude, we're like awesome. We beat up the freshmen in dodgeball. Like, come
Literally, it
on.
was like 15 freshmen.
That's just brutal. Okay, that's brutal. Okay.
Still, hey, a win's a win.
So, okay, actual items of business. A, I have nearly every one of your quizzes and all of your stuff. It's all graded. It's just sitting here in my notebook instead of on campus. Okay? So, I apologize that I haven't been getting that done. That's not really my style. I might go in 2-week bursts, but not like this. Life happened. The first couple weeks of school here have been pretty rough. For 2 weeks of it, I've had 1 or more children sick at all times. I mean, you saw Goblin number 2 had to run around here because we were just that hosed and we didn't know where to put them. Okay, I've been over to the clinic 3 times now because of sick kids. Just, we're up in the middle of the night with them. It's been a trip. So that means I don't have stuff in campus like I should. That's on me, not on you. I try to be flexible with you, hoping for the same in return. Okay? The reason I talk about that is, y'all know what Thursday is. Midterm. Okay? Yeah, midterm already. Which means I like having all of your stuff in on a regular basis. You know, 5 days quiz, 5 days quiz. I like having it in there on a consistent schedule. And instead, you're just going to get a big grade dump of whomp, here's 3 or 4 quizzes, which gets the haymaker to the grade. The grade exists out of nowhere, which is exactly what I try to avoid in my classes. So I'm sorry for that. Life happened. Okay? I really do feel bad about that. Midterm is on Thursday. That means if you are missing any quizzes or work as of Thursday, and we have not had a discussion, then to put in the midterm grade, I mark it as missing. Okay? If we haven't had a discussion. If we have had the discussion, like, hey, I just haven't been able to make up this quiz from last week because we had an advisory day and then there was a homecoming thing and I'm just not able to come in. Could I do it on Monday morning? Okay, fine. We've talked. So I won't mark it as missing. I'll do it as soon as you do. Okay? Just so you know that the midterm is coming. If we haven't had a discussion about something and it's missing, I mark it as missing. I still take it. You can do the quiz 5 weeks later. I don't care. I'll still put it in. It's when we start getting to the end of the semester, like those last 3 weeks, that's when I'm going to tell kids, okay, deadline. If you don't have this stuff in by this day, I'm not going to take it anymore because I don't want to be doing 30 quizzes, grading piles of notebooks just in the last 3 days of the semester. Okay? But I will still put things in later if just life happens, like it did. With that comes Friday. Y'all know you don't have school. We're stuck in meetings all day, bored to tears. But you all get Friday off. Because it's the end of the midterm, or it's the midterm, that means next week, Wednesday morning is when the grades are due. So not just for me, but for other teachers, don't be surprised if the midterm grade isn't finalized until Tuesday night. Okay? You got 100 some kids you got to put stuff in for. That also means next Thursday, parent-teacher conferences. It is a maroon early release day. So just like Friday, if you're not locked down in Spartan time as of the new Spartan time list that gets released on Wednesday, you can just peace out at lunch. Okay? So far in here, the quizzes look solid. Okay? We have a couple that are in a rough spot. You can tell who doesn't do their work, who's not really paying attention. You got a couple who I know they're trying, but they're not asking questions. They're not going anywhere past, I came to class and I wrote things down. If you're struggling and you're not asking questions, well, don't be surprised if you're stuck in Spartan time. Okay? You have to participate in your education. There used to be a time where I would sit down for dinner every night and my phone was ba-ding, 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 going bonkers because everyone was sitting down and doing their homework right before or after dinner. I would have 20, 30 messages a night. Kids asking questions. Something changed. I don't know why. This is the whole math department's talked about this. Kids just are less willing to ask questions now. 5 years ago, it was not uncommon for me to have 20 questions a night. Now, I might get 6 or 7 in a week. If you don't like what you see on campus once the grades are in, what are you doing to change that? Okay? I'm not asking for blood, sweat, and tears math. I'm asking for something as simple as like Ava pops in every now and then and just, here, I'm going to burst you with 5 questions. What about this? What about that? Why is this negative? Oh, okay, that makes sense. Bye. And then she's gone. Like, it's rapid fire. You're in and out of my room in like 3 minutes, right? But that little bit of clarification does amazing things. And that's all I'm asking for. So, midterm is Thursday. Grades will be in and finalized for the midterm for Spartan time and eligibility as of Wednesday morning next week. Thursday next week is parent-teacher conferences. Y'all get out early. We get in some dinky meetings for a couple hours, and then we have 15 minutes to eat dinner at 3:15, and there's already 2 parents in our room. Parent-teacher conferences. Most of you are, what, juniors, right? Did we have a few sophomores? Oh, no, this was a sophomore class. Okay. Most of you are in that sophomore to junior range. If that's the case, you should know how parent-teacher conferences go, even though it's been kind of weird for a year and a half. Most 99% of the things that I will say to parents, it's on my website. Like, in fact, that's usually what I do, is I do a quick video. I send out an email blast on campus to all parents and students and say, look, this is where everything is. If you have questions and you haven't already looked, you need to look here. Most of your questions can be answered here. I put everything out there. I'm as transparent as possible. And then if you still have questions, by all means, come in. I'd like to talk to you. I blab too much. So my parent-teacher conferences aren't the 5 minutes, you know, the person who's got the line of like 60 people outside the room. It's not like that. I get maybe 8, 9 the whole night. And during that time, it's usually just me BSing with parents. Like, I don't know, it's pretty tame. So if you just need an ego boost, maybe you're trying to convince your parents to buy you a new phone or a puppy or something, okay, send them my way. I'll talk you up. All right? Because most of you are doing good. Yeah, so that's a bunch of stuff for next week. Right? I think that's everything. Okay, here we go. We left off with 3 variable systems. It sounded like we were kind of getting the hang of it. Some of us preferred substitution. Some of us preferred elimination. But remember the goal? Eliminate a variable 2 different ways. Cool, now I have a 2 variable system. Solve it. Go back, find the variable you eliminated. The catch is you don't eliminate an x with this set and then a y with this set. If you do that, you're going to be confused every time. You're just a Yorkie chasing your tail, okay? I eliminated a y. Cool, do it again. But do it again a different way. Like if I use equations 1 and 3 to eliminate x, I cannot use equations 1 and 3 again to eliminate x a different way, or I'll end up with 2 of the same equation, which is the identity, and then you'll think there's infinite number of solutions. So we did substitution and elimination. What I'd like to show you here is that sometimes it is just set up for substitution. Usually you'll get word problems set up this way. So this. It's not all in standard form, right? It's not XYZ number, XYZ number, XYZ number. Instead, if I say R is this stuff, well, replace R with stuff. So I'm going to replace this R and this R with that stuff. So that's 5, 3s plus 1 minus 4s minus 3t is 3. Now, why did I leave a blank right there? Well, if I plug this in, right, t is s plus 3s plus 1. Well, then t is 4s plus 1. Well, if t is 4s plus 1, then replace t with this stuff. Substitution. If R is this stuff, replace R with this stuff. If T is this stuff, replace T with this stuff. Now, that top equation just became one big long thing with only S, one variable. You're off to the races. You say 15 S's plus 5 minus 4 S's minus 12 S's minus 3 is 3. Combine like terms. 15 things minus 4 things is 11 things. 11 things minus 12 things is negative 1 thing. 5 minus 3 is 2. And if I know that S is negative 1, well, we rewrote R and T in terms of S. Plug it back in. Now I plug a negative 1 here and here. Negative 3 plus 1, R is negative 2. Negative 4 plus 1, T is negative 3. How do I write my answer?
XYZ.
But it's not XYZ.
It's T. Oh.
It's
RTS.
How many of us have to actually sing the full alphabet song to remember alphabetical order?
That's not me.
A, B, C, D, F, G, H, I, J, K, L, M, P, S, Q, R, S, T. Okay, R, S, T, right? Most of the time when you have a coordinate that involves variables that aren't x, y, and z, we put it in alphabetical order. You don't have to, but that's usually what it is. So I got a -2, -1, -3. Someone in here is really bothered that that did not go 1, 2, 3. Someone in here is twitching about that. There's always that kid. Like, it's supposed to be 1, 2, 3. Why isn't it 1, 2, 3? So, sometimes they're set up for substitution. Other times they're set up for elimination. You know what? I'll actually come down here. What do you think is the easiest to eliminate?
Z.
Oh, Z.
Z. One cancels out, or two cancels.
Okay. Personally, I see a coefficient of 1, -1, 1, -1. I could easily get rid of any of them, right? I think it's easier to get rid of z's because there's a 1 and -1. There's two equations that have just a single 1 or -1 coefficient. So that's how I'm going to do it. I told you I'm an elimination guy. If you are a substitution kind of person, there's nothing wrong with turning this into x is -2y plus z plus 5. Plugging it in and going to town. You can do that if that's your jam. In my experience, most kids would rather do the elimination. Most. That doesn't mean you have to. I'm going to go elimination style, though. I'm going to label my equations and say equation 1 and equation 2. Well, if I just add those, everything's great. X minus y plus z is 4. X plus 2y minus z is 5. Womp. Getting 6x plus y is 9. I'm going to do it again a different way. That was one way that I got rid of z's. Get rid of z's another way. Okay. Could I use the second equation? By a -3. And that's why I personally prefer equation 1. Because if I multiply by a negative, it's one more thing I might screw up. Okay? So I'm going to say 3 times equation 1. You see how when I write that, you know what I did? So 3 times equation 1 is 15x minus 3y plus 3z is 12. Equation 3, 2x, 3y minus 3z is 5. And wait a second. Happy Christmas land. 17x is 17. Doesn't always happen. Okay, both the y's and the z's cancel. This doesn't always happen. But when it does, it's pretty nice, right? If that happens, when I go to my two-variable system, I'm going to say divide by 17 along the way and say 6x plus y is 9, but x is just straight up 1. So 6 by 1 plus y is 9, y is 3. And now that I know x is 1 and y is 3, I can go all the way back to one of my original equations. Which one should I use? Well, it doesn't matter. But most folks are going to say number 1 because a coefficient of 1, positive 1. Most folks. You don't have to. You can use any of them. 5 by a thing minus a thing plus z is 4. And we said x is 1. We said y is 3. So 5 minus 3 is 2. Subtract 2 on the other side. Z is 2. I write my answer as a three-dimensional coordinate. 1, 3, 2, and that same person is now, like their eye is actually twitching. Like, just got problems with it, got beef with it, okay? But that's where we left off. Just a little bit of review. We don't have to do this one, but I'm just going to ask a conceptual question. Look at the third equation. There isn't a y. So what should I eliminate?
Should eliminate y.
Let's do the y.
I already have an equation without y. So eliminate y again. Right? I already have x minus z is 5. If I use equation 1 and 2, all of a sudden that becomes a lot easier, right? Because you already have an equation that's missing a variable. So eliminate that variable again. You don't have to run that one all the way in. I just wanted to talk about if you see an equation that's already missing a variable, focus on eliminating that variable in another place. What I would like, show me that you can do it. What's goofy about this? It's all scrambled up, right? So let's start by writing it in standard form. 2x plus 4y, I'll have to add this z over, plus 3z is 6. How do I rewrite the second one? Then plus z. X minus 3y, I'll have to move him over. Minus 2z, that hasn't changed, is negative 7. So sometimes you got to do a little legwork ahead of time. Then you're off to the races. Just to make sure that everyone's doing the same thing, if you would please, let's all get rid of x first. Okay? Go! Talk. Argue with your neighbors. Suppose I never actually did hers. Attendance.
Oh, no.
Cool.
You did 10y minus 3. Okay, this one's after.
1, 3. 1, 3, 2. -2. 2, -2. 8, 1, 16. 1. 7. 2. So that's damn it. 3, 8, 24. Zero. 2, 0. I gotta check it. I'm exhausted. I gotta check it. Okay. 2, 4, 3. -2, 1, -5, 1, -3, -2, -7. -1, 2, 0. Get wrecked, math. Okay. You have math questions? You don't who what?
I don't think so.
Okay. Yeah.
So whenever you just always flip these.
Yeah, because if your domain and range swapped, then so do your labels.
That makes.
That's it.
I got it.
Okay.
This you're solving 1 to 7.
And what, you subtract those two equations? You're pretty straight. What equation? I got it. What?
Equals. And then. Okay. There's where I took it. Doesn't have to be how you did it. I said -2 by equation 2. And then I negated one of the equations so I could use equation 2 and 3 to cancel out. Getting now that's me. Remember, there was 6 different ways, 7, 8. Yeah, there's at least a dozen ways that you could have started this. Just getting rid of x's. So from there, if I have 8y plus z is 16, y plus 2z is 2, 3z. Said, I'm tired. I'm tired. They got all 3 on me last hour. So, okay. If I have this, most kids, not everyone, most kids are probably going to take this times a -3. Negative 24y minus 3z is -48. And y plus 3z is 2. Getting -23y is -46. Divide y is 2. If I know that y is 2, come back to either one of those 2 equations and say if y is 2, actually I'll use the first one because then I don't have to divide at the end. 8 by thing plus z is 16. If I know that y is 2, I now have 16 plus something is 16. So z is 0. And if I know both of those, come back to the originals. I'll use this one since it's just right there. I'll say x minus 3 of these minus 2 of those is -7. They happened to be 2 and 0. Getting x minus 6 is -7, so x is -1. So, 3 variable systems, we've been chipping away at it like it was half a day, half a day, half a day, because our schedule was just weird. But I'm not asking if you like them. I'm asking, can you do them? Okay. All right. Then Satan said, let there be words with math. Okay, the three variable systems for these actually aren't bad, because what they're going to do is give you a three variable thing, and then they'll say something really easy like, you want 4 times as many brownies as cookies. Well, there you go. Brownie equals 4 times cookie. B equals 4C. It's just a straight replacement. Okay, so they're not bad. You have a store, you gonna $6,000 to restock 200 shirts. That alone, what are those? You have $6,000 a total to restock 200 shirts. A total. Those are two different totals. More specifically, because they're two different totals in two different labels, I'm going to have 6,000 as a total, and I'm going to have 200 as a total. You can buy t-shirts for 12 bucks, polos for 24, rugby for 36. Those are three different things. Off to the side, perhaps I should write, do you want to do XYZ, ABC? Do you want to make it match this and say like T, P, and R? Ooh, controversy. I'm hearing the louder people say XYZ, and that's how our democracy works. It's not actually, democracy. It's just the louder people. Case in point, the recount that went absolutely nowhere in Arizona. 12% said, we want to, and then they did the recount and found out that it was actually worse against their favor. Way to go. Like, oh, our system is so screwed. How many of you are in government right now? Oh, no, you're juniors, right? Sophomore. God, I'm tired. No. Yeah, that's the kind of running joke among seniors who take government is go learn how our government's supposed to work. And then it doesn't. Okay, so if I'm going to say XYZ, maybe next to it, I should write what they are. T-shirts, polo shirts, and rugby shirts. Okay, so now that I have stated what is what, you have to define your variables. Now I can come over here and say, the first one's about money. I should put stuff with money. So $12 as the rate for X, 24 as the rate for Y, and 36 as the rate for Z. Right? What's the second total about? Just the amount of shirts. So I don't need a rate with them. It's just straight up this many shirts plus that many shirts plus that many shirts is 200 total shirts. And you think, how am I ever going to do this? And then you get to the next sentence. Twice as many rugby shirts as polo shirts. Rugby shirts, or wait, no, we said that was Z. Rugby shirts, twice as many rugby shirts as polo shirts. So if I double my polo shirts, I will know the rugby shirts. You see how they actually ain't that bad? It's a 3-variable system, but they're just straight up going to tell me, hey, substitute here. And now it's a 2-variable. So if I take 2y and I put it here and here, now this instead becomes 12x plus 24y plus 72y is 600. That becomes x plus y plus 2y is 200. Me. Okay. And then combine like terms.
Couldn't you just divide 6,000?
Okay. Can you, anywhere along the way, make your life easier instead of multiplying by dividing? Yes, you're exactly right. So this is 12x plus 96y is 6,000. But could I divide that by 12 and instead call it x plus... You sure? You sure?
Well, what is
It is 8.
it? Hey, I assume, why'd you make me say that? 8.
500. And then x plus 3y is 200. Okay, if I can take this and divide it by 12, right? Now, did I have to do that? I could have just taken the one below it and take it times a negative 12. Like, that's fine. Doesn't matter. Okay, something that the book occasionally does, but we haven't explicitly talked about. Do you know that you can, instead of multiply by a negative, you can just subtract an equation? Subtract this. The thing is, a lot of kids will forget to subtract each thing and accidentally add one of them. But it is a thing you can do. X minus x is gone. 8y's minus 3y's is 5y's. 500 minus 200 is 300. Divide and get 60. So if I know that y is 60, I just subtracted this instead of multiply by a negative. Wait, but? Okay, we said if z is this stuff, I'm going to replace z with this stuff. So here was my original. I then replaced z and then combined like terms and solved my two variable system. If I know y is 60, then I can say x plus 3 by 60 is 200. Well, that's 180. So x is 20. And if I know that y is 60, we just said, z is 2 by 60. So at the very end of it, I now know x. I got 20 t-shirts. Y. I've got 60 polos, which is just a t-shirt with a scrap of fabric on the collar. And rugby shirts. Which is just a long sleeve shirt that is very, very jarring in terms of its color. Okay, so the word problems are not They're not actually 3-variable systems in terms of how we solve them. They're going to break down to just, hey, replace this. It's 2 variables now. Just cross out the got it for so I remember we don't do that. It's the exact same thing, but they change one of the numbers. Instead, let's go back to geometry.
Oh, angles.
Yeah. Let's see what you remember. When in doubt, draw it out. Okay. Fair. That's fair. Triangle P, Q, R. This is probably not drawn to scale. I just made a random triangle and went with it. Okay. Measure of angle Q is 3 times the measure of angle P. So Q is 3P. The measure of angle R is 20 more than. You remember what that does?
Plus 20 plus P.
Plus 20 at the end. Now, because addition, it won't matter. But P plus 20. 20 more than P. And then the part from geometry that you need to remember, triangle sum theorem. Every triangle's interior angles will have a sum of 180 degrees. Get it?
I don't know.
But you learned that in middle school. Normally, chapter 4 is about a 2-week long adventure, so yeah. Yeah. Maybe 3. Depends how slow the class is. So all I have to say is P plus 3P plus P plus 20 is 180. Instead of saying P plus Q plus R. Jam it all together, I got 5 P's. Plus 20 is 180. P is 160. Divide. P is 32. If P is 32, then measure of angle Q is, you remember writing it like that?
Yeah.
Measure of angle Q, because now I'm specifically talking about it in terms of its measure number, is going to be 3 by 32 or 96 degrees. And this measure of angle R is going to be 52 degrees. So this is most definitely not drawn to scale. Instead, it should be more like that. Okay. little bit of review then. If you were to run across problems like this where they have a geometric component to it, what are complementary and supplementary angles? Okay. Complement, whoa, what? What? Make stop, make stop, make stop, make stop. I had some blue screen of death on there and it had a bunch of like written in 4 different languages, so that ain't good. I was gonna send you a meme about complementary angles. Yeah. So yes, complement comes before supplement, adds up to 90 versus adds up to 180. Oh, you know what? While we're on that train, I would like for everyone to have line L, line M, line J, line K with angles 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and simply putting this does all kinds of wondrous things. Figure out the other 15 angles. Go. All right, I need to read.
Is it 80? Yes. Don't be dumb. Yeah. 16. Yeah, 14 mistakes. And then the other ones would be 15 and 13.
All the even numbers are 4.
That's just right.
4, 6, 8, 12, 14, 9. So 9 do we have to add?
That one you don't? Yes. Yeah. It's a straight line.
No, you can start 40 and then the rest are.
That's what I got. Yeah, 140 and this.
Yeah, easy.
Literally.
Red are all the same. 40 degrees apiece. So what does that make the rest of them? 140. Green are all 140. Okay. Now, the question is, do you remember what they're called? Okay. What would this and this?
Outside, opposite, inside. I don't know.
Okay. Headed in the right spot. Okay. You just use big kid words for what you're saying. You're saying opposite, outside, alternate exterior angles. Alternate exterior. Okay. What about those two?
Inside, interior.
Consecutive interior. Because they're one right after the other. If you were to follow that path, Tron style. Okay. What about vertical angles? Okay. What about corresponding? Because they correspond to the same location. Okay, so just a little bit of review. Then we get rid of this and jump straight into 4.1. Your homework is just, hey, don't you start this, Frank.
Frank.
Come on now. There we go. That's better.
Did we? I don't know.
All right, everyone got the packet? Ready to roll? Okay. What's that thing called?
Quadratic.
Well, it is a function. It's called a parabola. The parabola is the graph of a quadratic. Okay? It's almost like it says it right above that. A quadratic. The function of x is x squared. That is the simplest that particular type of function will ever get. What is it called when this is the simplest this family of functions will ever get? The parent function. Okay? The parent function, x squared, starts down at 0, 0 with a vertex. Vertex, just like in our absolute value equations, is where it stops decreasing and starts increasing, or vice versa. Just like our absolute value, it's going to have an axis of symmetry. Unlike our absolute value functions, make them curvy. Okay? Eat some potatoes, girl. All right? They should have a little junk in the trunk. If you turn this into a V in your graphs, we're going to, you, me, skate park after school, okay? Or, well, skate park because that's city owned. You don't fight on school grounds because that's stupid. So.
Oh, I thought it was because you were
Yeah.
No. The curve for it, oh yeah, hey, skate park, yeah. No. This should actually have a curve to it, and before I do anything else, before I go on to anything else, I don't know if you remember how to graph biperfect squares. So you all know slope, right? Rise, run. But quadratics will always work because the parent graph is x squared. They will work by squares. So here's what I mean. From the vertex, over 1 up 1, because 1 squared is 1. Over 2 up 4, because 2 squared is 4. That's how you make a quadratic. From the vertex, I will go over 1, up 1. Over 2, up 4. Over 3, up 9. Squares. Squares. Over 4, up. Okay, so you need to know what your perfect squares are. I tell every one of my classes, all the way down to Algebra half, if you're going to be in high school, the same way you should know your multiplication facts in elementary and middle school, you should know your perfect squares through 20, cubes through 10, fourths through 5, as many powers of 2 and 3 as you could possibly memorize. Because they will happen that often. So, does anyone off the top of their head know what's 17 squared? 289.
I only know the 13.
13 squared. 19 squared.
368.
361. Okay. Who knows off the top of their head 7 cubed?
343.
Dirty cheat. Okay. You need to know these. They are that important, especially for this class. So if you do not, everyone got a graphing calculator on hand? A quick way to get the table of your squares, cubes, fourths, and so on. Go to y equals. Actually, I'm just going to... Oh no, I was doing things in here before. I want all of that gone. How do I get rid of it? Second plus 7, enter 2. See how much faster it is now that we got rid of Frank's x? Okay. Second plus 7, enter 2. Head over to y equals. Not in y1. Go down to y2. There's a reason for this. Type x squared. X to the third. X to the fourth. X, oh, get out of there. X to the fifth. Okay. Do you see why I started at y2? Because when I now go to my table, my auto-populated table, it's a table of your squares, cubes, fourths, and so on. When I ask, what is 7 cubed? 343. Okay? Don't look at the graph, just look at the table. Like, if you really quick want to know what all of your cubes are, what all of your squares are, you just come over here. Alternatively, something that you probably did at some point in middle school, maybe Algebra 1, what I've always told kids to do is to write your 121. Oh, come on.
Numbers.
121, 144, 169, 196, 215, 256, 289, 324, 361, and then 400. What I always tell kids, know your fourth power through 5, your cubes through 10, your squares through 20, and then as many powers of 2 and 3 as you can memorize, because they just happen a lot. It's not uncommon to have to deal with 2 to the 7th. So just know those. Put them on a note card. Smack it inside your calculator lid. Leave it there. Okay, you know what's up. It's just something that I recommend. Okay, now, that aside, I need to know that because Chapter 4 is all about quadratics. If you don't know how quadratics work, we're going to review it. Everything that we're about to do, all the way through section 4-8, the first 7 sections of this, it's all review. You did all of this in Algebra 1. The first half of algebra is supposed to be all about lines. The second half hits quadratics hard, introduces rationals and radicals, and exponents, I suppose. Now, do you remember our families of functions? Remember translating left and right, up and down? Do you remember vertical stretch, vertical compression, reflection, all that stuff that we did with other functions? We're going to do the same thing here. You know what? I don't like that they have you do they want you to do it by table. You know what? We can do it by table. I'll just show you what's going on here. If I'm going to graph this, my original, you don't have to graph this part, I'm going to do it. My original, vertex at 0, 0, perfect square steps, over 1, up 1, over 2, up, over 3, up, over 4, up, off-road, right? And it has an axis of symmetry. So what I do to one side, I do to the other. If this is 1 to the right, go 1 to the left. 2 to the right, 2 to the left. 3 to the right, 3 to the left. You connect them, try to keep it curvy. Try to actually hit the dots too. If that's the original, what is this going to do? Vertical compression by a factor of 1/2. It's in that A spot. So I take all of these points and say, if I would go over 1 up 1, I'll go over 1 up 1/2, right? Half of that. If I would go over 2, I normally go up 4, I'm going to half of that. I would go over 3, I would go up 9 halves. So there's 1, 2, 3, 4, half. And I say make as many as you can. Normally I would go over 4, I would go up 16. But instead I will go up 8. I'll go over 5, I'd go up 25 halves, which is 12.5. Okay? You take all of those perfect squares and you cut them in half. And then mirror them. Shoop, 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 shoop. I always wiggle on the right side. Every time. Okay. Now, let's say I have no clue how to graph this. I don't know how perfect squares work. How can you graph anything? Now, what I don't want to see... No, you're right. But what I don't want to see kids do is come over here and clear, 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 clear. What I don't want is for Callister to see that on his paper and then just move on.
Perfect.
I'm sorry, does this hit these exact points? Actually, I kind of winged it, and that turned out all right. But if I don't see the points, make a note to yourself. Like big, highlighted, flashing neon, the exclamation point above the guy saying side quest here. If I don't see the actual points on there, I'm just going to mark it wrong because you're just winging it. Okay? Have some points on there to show, even if your graph sucks, you are trying to hit these points. Some of you can't aim worth it, especially the guys. Okay? If y'all in a household with anyone who does not have a Y chromosome, please, pea sitting down. They will thank you for it. Because you have terrible aim. Okay? There's a reason the guys' bathrooms are disgusting. It's because guys are disgusting. So, what's going to be different about that? Okay, it's going to reflect downward, and you're going to take all those perfect squares, you're going to cut them in a third, which means it'll go on the bottom half of the graph up there, and you have room for it. Go. Either do your perfect squares and cut them in a third, divide them by 3, or go to the table and plot points. I don't care. As long as you can graph it. Yes, ma'am. Okay.
So, like, I'm very confused right now.
Okay, what about it?
So I'm trying to I plug H in for G, right? So I plug x squared minus 6 in for...
Maybe it would help if you wrote out square root of x plus 3 times square root of x plus 3.
Minus 6. Not freshman G. Okay, I got you.
Right?
Yeah.
Because you're going to square this one, you're going to square that one, but you're going to have 6 square root of x in the middle.
Thank you so much.
Yep, yep.
The second one would be.
Wait, so this thing?
No.
Oh, okay.
Wait, that can't be right.
Now, the way they kind of want us to do this old school, remember doing this? Okay. If I square those, I get 9, 4, 1, 0, 1, 4, and 9 respectively. What we're going to do, take all those times a third. So now it's at -3, 4 thirds, negative 1 third, 0, negative 1 third, negative 4 thirds, and negative 3. Okay? So, I start with 0, 0. Over 1, not up 1, down 1 third. Over 2, not up 4, down 4 thirds. Over 3, not up 9, down 9 thirds, which is negative 3. Now, I can keep doing this, say negative 16 thirds, which is 5 and third. 1, 2, 3, 4, 5 thing. I could go to 25 thirds, which is negative 8 and a third. I could go to 36 thirds, which is negative 12, and mirror them over. But if you have to graph by table, here's a little trick that you can do. How about, since I know I'm going to divide all of them by 3, why not only do the perfect squares that are divisible by 3? So if you know your perfect squares, well, 1 is not divisible by 3. 4 is not divisible by 3. 9 is divisible by 3. So over 3 down 3. 16 is not divisible by 3. 25 is not divisible by 3. 36 is. So I'll go over 6 down, not 36, 12. So if I only had these points, if I only had those, would you still be able to see the curve? Which is another note that I would like you to make for yourself. I personally, I always make as many points as I can, but a minimum of 5 points. The vertex and 2 on each side. Because with 2 on each side, you can usually see the curvature. And then connect the dots. Whoa. Swing and a miss. Minimum of 5 points. Now, here's another trick. We can't do it on this one because we already have a graph on there. Check this out. What if I did 1, 3, 9, like this? That is currently incorrect. It is now correct. Change the scale to match the compression. That's sneaky. Because now, this is over 1 down 1 third. Over 2 down 4 thirds. Sneaky, sneaky.
That'd be 3. 3 thirds would be 1.
I meant to go there.
No,
Okay, yeah, that's a genuine screw up right there. That's bad.
Wait till the first one doesn't count.
What first one? What?
666,000.
Did I not put it? Okay, you guys all be quiet. You be quiet. I don't trust any of you. Ladies,
What?
did I not put it up there? Okay. All right. So, on this page, they write all of our different types of... I bit my tongue. Ah, son of a fucking fish.
Wide orientation.
Ah! Ah. Ow. All right. Let's try this again. They write all of the transformations separately here. We can write that in our big old transformation form. Y is A. Y'all see it right here. If A is negative, it's going to have a vertical reflection. If A is greater than 1, it is a stretch. If it is less than 1, it is a compression. We will likely not see B. I said when we did our function family stuff earlier, you actually probably saw B more there than you will the rest of the semester combined. Because if I have like 3x minus 2, the quantity squared, can't I just write that as 3 squared times x minus 2 squared?
Yeah.
Because they're both getting the exponent? Yeah. So I can turn any B into an A. So it's very, very unlikely that we're going to see a horizontal stretch or compression, a horizontal reflection. But I'm still going to put it there just in case. So we know it didn't disappear. It's just we're likely not going to use it. H. Right there. Bass-ackwards land. It's still moving it left and right. And K. My vertical translation. Up and down. Okay. This is our transformation form. Hopefully you remember all the stuff. A couple of notes that I would like you to write next to this. 1. You know what? I might be able to do this in one shot. My vertex is always at HK. Same as it was with our absolute value. If I move to the right x, I will then go up or down x squared, right? That's our perfect squares steps. Over 1, up 1, over 2, up 4, over 3, up whatever, times whatever A is. That's how I get my graph. Just like I went over 1, down 1/3, over 2, down 4/3. Because over 2 squared is 4, but I took that 4 times the negative 1/3 in the A spot. Okay? This is how you're going to make your graph. So you go find your vertex and then use your perfect square steps to finish it off. Okay? Oh, didn't explicitly say it, but parabolas are known for their vertex having a special name, the maximum or the minimum. Pretty easy to figure out. The minimum is the lowest point, the maximum is the highest point. Where that comes into play, hate to say it, word problems. Wow, that was forceful. Nah. Because you'll have a word problem that generates a parabola, and they'll say, how can I maximize the area of this dog pen that I'm making using only these materials? How can I minimize the costs for this project? Blah, 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 do what you just did, go find the vertex. Okay? So, with that in mind, here we go. Graph the function. How is it a translation of x squared? That -5, what spot is it in? A, B, H, or K? How do I know it's K and not H? No parentheses. So this one is going to move 5 units where? Downtown. And I will say right next to it, it is a vertical translation down 5. Use your big kid words. And from the vertex, now at 0, -5, just do your perfect square steps. From here, over 1, up 1. From the vertex, not the last point, from the vertex, over 2, up 4. From the vertex, over 3, up 9. So there's 1, 2, 3, 4, 5. Over 4, up 16 is just off-road. Then, mirror them across your axis of symmetry. Connect the dots, try to keep it curvy. Okay. What is different about B? The parentheses indicate that 4 is in A, B, H, or K? H. So if it's in the H spot, am I moving left, right, up, or down?
Right.
Say our big kid words, we're going to have a horizontal translation right 4. So I will start my vertex at 4, 0. From there, perfect square steps. From the vertex, right 1, up 1. From the vertex, right 2, up 4. From the vertex, right 3, up 9. Mirror them across an axis of symmetry. Connect the dots, try to keep it curvy. We like Beyonce, not Amanda Seyfried. She's in a lot of chick flick movies. Super skinny, scrawny. Kind of got bug eyes, like a pug. What's one of her more famous? She's in the Mamma Mia movies. If anyone watches those, my wife's obsessed with them. Okay, if you can do that, you can do those. Go.
Oh, it doesn't even fit.
Yeah, it does. Do A with the A graph. Do B with the B graph. There's room. This graphing by perfect squares thing, y'all, I'll get kids who come up to pre-calc not knowing this. I don't know why. They just always did it by table or something. Okay. But it's not hard. You find the vertex and then just use perfect squares. Where it gets a little goofy is if you have a different scale and you have a stretch or compression. Then it gets a little goofy. I wouldn't mind you using a table to graph it then. Okay. Said if you know what you're doing, they're fairly quick. This one's up 3. 1, 2, 3. This is left 1. Okay. So your homework is just going to be the 3 variable system stuff. There's not going to be a lot of it, but each problem might take a while. So maybe you'll have 5 or 6 problems, but they'll take longer. Okay.